Number, complete display stack architecture. When we look at a display, we usually only see the final image. However, a display module is actually a complex system made of multiple layers working together. Understanding the complete display stack architecture is essential for designing a reliable and high-performance display solution. So, what is inside a display module? Let's explore each layer from the outside to the inside. Number Layer 1. Cover glass. The first layer is the cover glass. It provides mechanical protection and creates the user interface surface. Depending on the application, cover materials can include glass, PMMA, or PC. Surface treatments such as AG, AR, and AF coatings can improve visibility, reduce reflections, and enhance durability. Number Layer 2. Touch panel. The next layer is the touch panel. It allows users to interact directly with the display. Common touch technologies include projected capacitive touch, also known as PCAP, and resistive touch. For modern applications, PCAP touch is widely used because of its excellent sensitivity and multi-touch capability. Number Layer 3. Optical bonding layer between the cover glass, touch panel, and display module. There is usually an adhesive layer. Traditional displays may use frame bonding with an air gap. Advanced displays often use optical bonding technology. Optical bonding fills the air gap with optical adhesive. It improves contrast, reduces reflection, and enhances outdoor readability. Number Layer 4. Polarizer. The polarizer is a critical optical component inside LCD displays. It controls the direction of light passing through the liquid crystal layer. Without the polarizer, the LCD cannot properly control brightness and image formation. Number Layer 5. LCD cell. The LCD cell is the core image-forming layer. It contains liquid crystal molecules controlled by electrical signals. By changing the orientation of liquid crystals, different amounts of light can pass through each pixel. This creates the final image. Number Layer 6. TFT array and color filter. Inside the LCD cell are two important structures: the TFT array and the color filter. The TFT array controls each individual pixel. The color filter creates red, green, and blue subpixels to produce full color images. Together they determine resolution, color accuracy, and display performance. Number Layer 7. Backlight unit. Because LCD panels do not generate their own light, they require a backlight system. The backlight unit includes LED light source, light guide plate, diffuser film, and brightness enhancement films. It provides uniform illumination across the entire display area. Number Layer 8. Driver IC. And FPC. The driver IC controls the display signals and converts electronic data into pixel information. The FPC, or flexible printed circuit, connects the display module with the main controller. These components are essential for communication between the system and the display. Number. Why does display stack design matter? Every layer affects the final performance. A poor optical design can reduce brightness and contrast. Incorrect material selection can affect reliability. Poor bonding processes can create bubbles or delamination. A successful display solution requires balancing optical performance, mechanical strength, touch experience, and manufacturing reliability. A display is not just a panel. It is a complete system where every layer works together. Understanding the display stack architecture helps engineers select, design, and optimize the right display solution for every application.